In this video, we will talk about quadratic formula method to find the roots of a quadratic equation. So let's write a general quadratic equation, which is ax square plus bx plus c. So the general formula to find the roots of a quadratic equation is x is equal to minus b plus minus under root d upon 2a, where d is discriminant and its formula is b square minus 4ac. And here a, b and c are the coefficients of the quadratic equation, which is written as ax square plus bx plus c. So this is the general formula which we will apply to every quadratic equation to find the roots. So let's solve some examples. So the first example is x square plus 5x minus 14 is equal to 0. So if we compare this quadratic equation with the general quadratic equation, which is ax square plus bx plus c, so you will see a is 1, b is 5 and c is minus 14. So the general formula to find the roots is x is equal to minus p plus minus under root d upon 2a. So first we will find d, which is discriminant, and the formula to find the discriminant is p square minus 4ac. So here b is equal to 5 and a is 1 and c is minus 14. So 5 into 5 is 25 and minus 14 into 4 is equal to minus 56. So minus minus is plus, so 25 plus 56 is equal to 81. So the discriminant is 81. So we will put the value of d in our general quadratic formula, which is minus p plus minus under root d upon 2a. So the value of b is 5, the value of d is 81 and the value of a is 1. So as we know, the square root of 81 is 9. 2 into 1 is 2. So there are two different equations. One is minus 5 plus 9 over 2 and the other one is minus 5 minus 9 over 2. So we will solve the first one, which is minus 5 plus 9 upon 2. So it is equal to 4 upon 2, which is 2. The other one is minus 5 minus 9 upon 2. So minus minus is plus. So this is equal to minus 14. So this is minus 7. So here you can see our two roots comes out to be 2 and minus 7. So this is how you can use the quadratic formula to find the roots of any quadratic equation. Let's solve one more example, which is 3x square minus x minus 2 equal to 0. So if we compare this equation with the general quadratic equation, which is ax square plus bx plus c is equal to 0, a is equal to 3, b is equal to minus 1, and c is equal to minus 2. So our general formula to find the roots is x is equal to minus b plus minus under root d upon 2a. So first we will find the discriminant. So here the value of d is b square minus 4ac. The value of b is minus 1. The value of a is 3. And the value of c is minus 2. So minus minus is plus. So here also minus minus is plus. So it becomes 24. So 24 plus 1 is 25. So the value of d is 25. So the formula is minus b plus minus under root d upon 2a. The value of b is minus 1. The value of t is 25. The value of a is 3. So if we calculate, minus minus is plus, so 1. As we know, the square root of 25 is 5. So 2 into 3 is 6. So we have two equations. One is 1 plus 5 upon 6. The other one is 1 minus 5 upon 6. So here, if we calculate, 6 upon 6 is equal to 1. And here 1 minus 5 is equal to minus 4. So here we calculate, comes out to be minus 2 by 3. The other one is 1. So the roots of this equations comes out to be 1 and minus 2 by 3. Let's solve one more example, which is minus x square minus 3x minus 6 is equal to 5x minus 8. So first we will solve this equation. So here minus x square minus 3x. So if 5x comes here, so it will become minus 5x minus 6 plus 8 is equal to 0. So the final equation is minus x square. So minus minus is plus, comes minus 8x. Here plus minus minus. So 8 minus 6 is 2 plus 2 is equal to 0. So our final quadratic equation is minus x square minus 8x plus 2 is equal to 0. So if we compare this equation with the general quadratic equation, which is ax square plus bx plus c is equal to 0, a is equal to minus 1, b is equal to minus 8 and c is equal to 2. So the formula to find the roots of a quadratic equation is x is equal to minus b plus minus under root d upon 2a. So firstly we will find the value of d, which is discriminant, and its formula is b square minus 4ac. So here you can see b is equal to minus 8, a is equal to minus 1, and c is equal to 2. So if we calculate, minus 8 into minus 8 is 64, plus minus 4 into minus 1 into 2 is 8. So d is equal to 72. So we will put all the values in the general formula, which is minus b plus minus under root d upon 2a. So here b is equal to minus 8 and the value of d is 72 and the value of a is minus 1. So if we calculate, minus minus is plus, so 8 plus minus under root of 72 over minus 2. So there are two different equations. The one is 8 plus under root 72 over minus 2, and the other one is 8 minus under root 72 upon minus 2. First we will find the square root of 72. So here we will take the LCM of 72. So 2 into 3 is 6. So 2 into 36 is 72. 2 into 18 is 36. 2 into 9 is 18. 3 into 3 is 9. And 3 ones are 3. So here we have 2 into 2 into 2 into 3 to 3. So here you can see, so the square root of 72 is 6 under root 2. So as we know, the square root of 72 comes out to be 6 under root 2. So this is equal to 8 plus 6 under root 2 upon minus 2, and here also 8 minus 6 under root 2 upon minus 2. So if we take 2 common from the numerator, so it is 4 plus 3 under root 2 upon minus 2. Same in the second equation, 4 minus 3 under root 2 upon minus 2. So here cut each other. So minus will go in the numerator. So minus 4 plus 3 under root 2. Here also minus 4 minus 3 under root 2. So the full equation is minus 4 minus 3 under root 2, and here minus 4 plus 3 under root 2. So the final roots of this quadratic equation comes out to be minus 4 minus 3 under root 2, and the other is minus 4 plus 3 under root 2. So now we will discuss how we will find the nature of the roots. In order to find the nature of the roots, we have to find the value of discriminant, which is d. So as we know, the formula of d is b square minus 4ac. So if the value of d is equal to 0, then we will have two equal and real roots. If the value of d is greater than 0, then we will have two real and distinct roots. And if the value of d is less than 0, then we will have no real roots. We will do some examples to understand this better. So here the first example is 3x square plus 6x plus 2 is equal to 0. So here if we compare this equation with the general quadratic equation, which is ax square plus bx plus c is equal to 0, a is equal to 3, b is equal to 6, and c is equal to 2. So as we know, the value of d is b square minus 4ac. So here b is 6, a is 3, and c is 2. So 6 into 6 is 36, and 4 into 3 is 12, and 12 into 2 is 24. So the value of discriminant is 12. So as I told you guys, if the value of d is greater than 0, then there will be two real and distinct roots. So in this case, the value of d is 12, which is greater than 0. So there will be two real and distinct roots. Let's find out. The formula to find the roots of a quadratic equation is minus b plus minus under root d upon 2a. Here the value of b is 6, the value of d is 12, the value of a is 3. So if we calculate minus 6 plus minus, the square root of 12 is 2 under root 3. 2 into 3 is 6. So there will be two equations. One is minus 6 plus 2 under root 3 upon 6, and the other one is minus 6 minus 2 under root 3 upon 6. So here you can see both these roots are different and real. So these are the final roots. Let's solve one more example, which is 5x square plus 6x plus 1 is equal to 0. So if we compare this equation with the general quadratic equation, which is ax square plus bx plus c is equal to 0, a is equal to 5, B is equal to 6 and C is equal to 1. So if we find the value of discriminant, which is B square minus 4AC, the value of B is 6, the value of A is 5, and the value of C is 1. So 6 into 6 is 36, 4 into 5 is 20. So D is equal to 16. So as we know, if D is greater than 0, so we will have two real and distinct roots. Now let's find out the roots of the quadratic equation. So as we know, the general formula to find the roots of the quadratic equation is minus b plus minus under root d upon 2a. As the value of b is equal to 6, the value of d as we calculated is 16 and the value of a is 5. So minus 6 plus minus under root 16 upon 10. So we will have two equations. First is minus 6 plus under root 16 upon 10. The other one is minus 6 minus under root 16 upon 10. So here, as we know, the square root of 16 is 4. So minus 6 upon 4 over 10. And here minus 6 minus 4 upon 10. So minus plus minus 4 minus 6 is equal to minus 2 upon 10. And here minus minus is plus. So 6 plus 4 is 10. Minus 10 upon 10. So the two roots are minus 1 by 5 and minus 1. So here you can see the roots are different and also not equal but are real. Let's solve one more example, which is 4x square minus 4x plus 1 is equal to 0. So if we compare this equation with the general quadratic equation, which is ax square plus bx plus c is equal to 0, a is equal to 4, b is equal to minus 4, and c is equal to 1. So if we find the value of discriminant, which is b square minus 4ac, the value of b is minus 4, the value of a is 4, and c is 1. So minus 4 into minus 4 is 16. So here 4 into 4 is 16. So the value of d is 0. So as we know, if the value of d is equal to 0, we will have two equal and real roots. Let's check out that by finding the roots of this equation. As the formula to find the roots of the quadratic equation is minus b plus minus under root d upon 2a. So the value of b is equal to minus 4. So our d comes out to be 0. The value of a is 4. So there will be two equations. The first one is 4 plus 0 upon 8. The other is minus root 0 upon 8. So the minus minus is plus. So 4. So square root of 0 is 0. So 4 plus 0 upon 8. And for the other equation, minus minus plus 4 minus square root of 0 is 0. 4 minus 0 upon 8. So 4 plus 0 is 4. So 4 upon 8. And for the other equation also, 4 minus 0 is 4. 4 upon 8. So this is 1 upon 2. And for the other equation also, 1 upon 2. So both the roots are equal to 1 by 2 and 1 by 2. So we can see if our discriminant is equal to 0, then the roots will be equal. As you can see, the roots comes out to be 1 by 2 and 1 by 2, and there will be real roots.